In this video, I'm going to be going over parametric equations. Usually, you're used to seeing equations in Cartesian form. So for example, y equals x cubed minus 4x. So Cartesian form is where you have y is some function of x. A parametric equation is where you're given two pieces of information that can be combined to make a Cartesian equation. So for example, if you're given that x equals 2t and y equals 8t cubed minus 8t, you would rearrange this equation for t because it's the most simple one. So from here you can see that t is x divided by 2, and then you substitute that into this equation. So you have y equals 8 times x over 2 cubed minus 8 times x over 2, and simplifying this you have 8 times x cubed over 2 cubed, which is 8, minus 8x over 2. So these 8's cancel and you get x cubed, and then the 8 and the 2 cancels to 4x. And that is the Cartesian form, and these two make up the parametric form. If you do another example, so if you're given x equals 1 over 1 plus 3t and y equals 1 over 1 minus 3t, usually you have y on its own and then the x's on the right hand side. So if we rearrange this one, so bring the 1 plus 3t up and you'll have x1 plus 3t equals 1, and then divide through by x and take the 1 across, and you'll have 3t equals 1 over x minus 1, and then just take the 3 across as well. So you have t equals a third 1 over x minus 1, and then substituting this in for t up here, you have y equals 1 over 1 minus 3 times a third 1 over x minus 1. Simplifying and expanding out this bracket, you have 1 over 1 minus, so this 3 and this third cancel, and you have 1 over x minus 1. I've lost something, there should be a minus there. And then you have 1, so this minus stays because it's plus inside, so it's 1 over x. And then minus and minus makes plus. So you have 1 over 1 plus 1 is 2 minus 1 over x. And then you can leave it like this, or if you don't like having a fraction on the bottom, you can just multiply through by x, and you'll have x over 2x minus 1. You're also expected to be able to differentiate the Cartesian equation given two parts of the parametric equation. So if we, before we do an example, the formula for dy dx is dy dt multiplied by dt dx, but it may be easier to remember this as dy dt divided by dx dt. So if we take the example x equals 4t and y equals t squared, if we differentiate each of these, you get dx dt is just 4 and dy dt is 2t, and putting these into this equation you get dy dx equals 2t over 4, which is just t over 2. This was quite a simple example, but there are also more complicated ones. So if you take one where x equals 1 over 1 plus t cubed and y equals 1 over 1 plus t cubed, No, it doesn't. It equals t over 1 plus t cubed. If you differentiate this for the x, you would use the quotient rule. So u equals 1, u prime equals 0, v equals 1 plus t cubed, v prime equals 3t squared, so x equals, sorry, dx dt equals 0 minus 3t squared over 1 plus t cubed all squared. So just simplifying gives minus 3t squared over 1 plus t cubed all squared. And you would use the same technique to find the y derivative. So u equals t and v equals 1 plus t cubed. U prime is 1, v prime is 3t squared. So dy dt is v dx, so 1 plus t cubed minus 3t cubed divided by 1 plus t cubed all squared. This can be simplified to 1 minus 2t cubed over 1 plus t cubed. And then putting into this equation, you have dy dx is dy dt, so 1 minus 2 t cubed over 1 plus t cubed, and then times 1 plus t cubed squared over, I've missed something, there should be a squared here, over minus 3 t squared. You can cancel these out and you have 1 minus 2t cubed over minus 3t squared. Multiply 3 by minus 1 and you're going to have 2t cubed minus 1 divided by 3t squared. And this is what the derivative of the Cartesian form would be. You also have to be able to integrate parametric equations, and the formula for this is the integral of y dx, which is the Cartesian one, is equal to the integral of f of t, so that's the y, multiplied by dx dt. So if we take the example where x equals t minus 1 and y equals t squared, so a for area equals the integral where t equals t2 and t equals t1, here t1 equals 1 and t2 equals 3. So the f of t is the t squared, and then dx dt is just 1, so it just multiplied by 1 is itself, dt. So you're going to have t squared dt, and these t's are 3 and 1. It's going to have t cubed over 3 evaluated at 1 and 3, which is 27 over 3 minus a third, which is 26 over 3. If you want to check this is the correct result, you can find the Cartesian equation from these bits of information and then do that. So from here you can see that the Cartesian form is y equals x plus 1 all squared, which if you expand out gives you x squared plus 2x plus 1. Integral of this is so for the limits, earlier we were integrating with respect to t, so we just had the t's as the limits. Here we're integrating with respect to x, and to get the x variables you do the t variables minus 1, so the top limit is going to be 3 take 1 giving 2, and the bottom limit 1 take 1 being 0. Evaluating this, and you get x cubed over 3 plus x squared plus x. Subbing numbers in, you have 2 cubed is 8 divided by 3 plus 2 squared is 4 plus 2, and all of these terms are going to go to 0 when you put 0 in, and add these together and you get 26 over 3, which is the same result as we had earlier. If you take another example where x is t squared plus 1, y is 2t, and the 2x values we're given are 2 and 5. So the area is the integral of, so y is just 2t, and the derivative of x with respect to t is also 2t dt. For the limits we were given x values and we're integrating with respect to t, so we need an equation for t in terms of x. So rearrange this and you get t equals the square root of x minus 1, and put these in and you get t is the 2 take 1 square root is 1, and 5 take 1 is 4 square root of that, and you get 2. So these limits are 2 and 1. So integrate this and you have 4t cubed over 3 at 1 and 2, which gives you 4 thirds. 2 cubed is 8 and 1 cubed is 1, and that gives you 28 thirds. If you do another example where x is 3t and y is 3 over t, you have the y being 3 over t, and the derivative of 3t is just 3. And for the limits, you would have x equals 3 and 12. So we need to have the limits being t equals 4 and 1, so that's from 3 divided by 3 and 12 divided by 3 to get 4 and 1. So 3 times 3 is 9, so you can take that out of the integral because it's just a constant. The limits stay the same. You have 1 over t dt, and this is a known integral of 9 ln, well, 1 over t is a known integral, and it's just multiplied by 9. So it's ln t, and that's at 1 and 4, which is 9 ln 4 minus ln 1. And using the log laws, you can just say that is 9 ln 4.